Magnetic force. If you happen to notice that some of the fish tanks can be cleaned by these two pieces of magnets, one piece outside and one piece inside in the water. So without even sticking your hand into the water, you're able to use this magnet to wipe the inside of a fish tank. So here is a question for you. How many newtons do you think a fish tank cleaner can actually pull to keep them together? That's for you to find out. We have learned different types of forces. In mechanics, first we introduced the four basic types of forces: gravitational forces, normal force, tension force, friction force. And then we introduced in liquid, there's a buoyant force. In the electricity magnetism, we introduce electrostatic force, and here we are introducing the next type, that's magnetic force. Magnetic force exists in nature, and here we look at particularly the magnetic force in one of the simplest forms. So what's simple about them? We start with magnetic force on a moving charge. So on a moving charge, the force is the simplest. So the force equals to the charge of this particle. So charge must be on some particle. And the velocity of the charge multiplied by the magnetic field at that particular location. This magnetic field is external to this moving particle. In other words, this magnetic field is not in any way generated by the moving particle, but it exists independent of this moving particle. So that's what we call an external magnetic field. The magnitude of the magnetic force on this moving charge is the charge of the particle times the velocity of the particle times the magnitude of magnetic field and the sine angle between them. For example, when the velocity and the magnetic field are forming an angle of theta like this, so this is sine theta, or in the one, this is an angle larger than 90 degrees. A commonly used angle in our exercises is a 90-degree angle. So do you remember what sine 90 degree is? That's for you to find out, to research. That was the magnitude. What about the direction? So we use the right-hand rule. So from Wikipedia, right-hand rule is defined by using your three fingers. If one points to the first vector, A, another finger points to the second vector, A, and your cross multiplication vector, the product of the cross multiplication of these two vectors will be pointing the direction as indicated by the direction of the thumb. So this is what we call the right-hand rule. So here's the question. For left-handed people, you can use left hand, right or wrong? Do research. Just to tell you the answer, wrong. If you're left-handed, you still have to use the right-hand rule. Sorry about right-handed people. And another thing is, another question, if I'm busy writing with my right hand, can I use the left-hand rule? The answer is you know. Examples. So here in the background, we have this little cross signs that represent the magnetic field perpendicular to the paper and pointing into the paper. And the direction of the velocity is here, V. This represents a little positive charge. So the force is, so your index finger points towards the velocity, and your middle finger points towards the direction of the magnetic field, and your thumb should be pointing upward, like the direction of the force. So this is one example. Another example, what if you have positive charge or negative charge? So first example, if the charge is positive, then the direction of the charge is your index finger should be pointing towards the right, and your middle finger should pointing towards the magnetic field, which is coming out of paper, and your thumb now should be pointing downwards. So the force at this point is downwards. That actually pulls the positive charge towards this direction. In case it's a negative charge, then Q is negative. The force is opposite. So the magnetic force on the negative charge is in opposite direction of what you decided with the right-hand rule for the positive charge. In summary, we here talked about the magnetic field. It's still measured in newtons, like all the other forces we have introduced before. So this is our 7th type of force. We talked about the magnitude of magnetic force on the simplest, in the simplest case, which is on a moving charge. And we talked about the magnetic field's direction using right-hand rule. And here we talked about an example, how to decide the direction of the magnetic force on a moving charge and how to decide the magnetic force on a positive or negative charge.